Here we're going to be doing now carboxylic acids and derivatives. First time that we're going to be doing is learning about what are those derivatives in the nomenclature, systematic nomenclature. So let's first draw what a carboxylic acid is. So, and this is, oh, that doesn't show very well, so I'm going to draw on top. Yeah, I guess that's better. So that is acetic acid. But IUPAC name of that, let's count carbons. So where my functional group is carbon number 1 and 2. So this is ethanoic acid. So here we notice from ethane, we're going to drop that termination A and E. We're going to add OIC and add the word acid for the IUPAC name. So again, that's the common name. That's the IUPAC naming. And of course, we're going to be taking into account the chain, the parent chain. And always a parent chain is where the functional group is attached. Remember when we're doing systematic IUPAC nomenclature, the first step is selecting the parent chain, and it must contain the functional group. If we have several functional groups, we need to prioritize, but it turns out that the highest priority of functional groups in regards to naming is carboxylic acid. And its derivatives have also higher priority. That is, if I have a molecule, such as this, let's make it. Here I have two functional groups. I have a carboxylic acid and alcohol group. However, this is my highest in priority functional group, so I'm going to assign the name for the carboxylic acid, and the carbonyl carbon of that functional group is my carbon number 1. So 1, 2, 3, and 4. So this is 3-hydroxy, and notice that when it is an alcohol, that's ethanol, right? So you are the termination OL, but when this is not the main functional group, you name it as substituent. So hydroxy, 3-hydroxy, and this is butanoic acid. Butanoic termination acid. And I wanted to add another element here, which is stereochemistry. When those elements are present, we need to add it to the name. So I'm going to draw here like the general strategy. Let's say, what are we doing first? We are looking for the parent chain when we're doing nomenclature. And this I'm going to put in a circle. That's what I did here, butanoic. I'm saying that I have 4 carbon atoms in my parent chain. Next, I need to in here, prioritizing my functional group. We did it already. We said that the carboxylic acid has higher priority over the alcohols, so this is the name. So we did this prioritizing the functional group. Then we're gonna identify substituents, and let's do this. I have a substituent, the hydroxy. So we name it, we know the name of that. We need to number the chain, and we did. In this time, remember, you're going to be giving priority again to the functional group. So I assign my carbon number 1, where the carbonyl of the carboxylic acid group is. So that's my numbering, I have it. Then if I have several substituents, I need to list alphabetically. So let's say that I'm going to add another substituent for fun. So I'm going to modify the name slightly because, let's say, now I want to add another substituent to my carbon number 2. So now I have a metal. So I have a metal in substituents and I have a hydroxy. I need to list alphabetically. So hydroxy goes before metal. So I'm going to say for the name that this is 3-hydroxy. And I don't have room, so I'm going to start copying it down here. So 3-hydroxy. And then 2-methyl butanoic acid. And now, last element here is stereochemistry. So if we have chiral centers, we need to list them and give the configuration. If we have a double bond, and it is, we notice different substituents could be E or Z, we need to list that as well. So to complete the name here, parent chain, and my main functional group is the carboxylic acid. These are my substituents. I have listed alphabetically. The numbers say where the substituents are. And lastly, I have 2 chiral centers. Because I have 2 chiral centers, now I need to list them. So I'm going to say carbon number 2. Let's find out the configuration. Carbon number 3. And we're finding the configuration. To do that, I'm going to just review so that we can complete the whole name. So this, I have videos about absolute configuration. Anyways, if you need help with that, so let me erase that. That's just a parent chain. To assign configuration, first step, saying quickly, let's say, here, you need to assign priorities. So at the carbon here, you will have an H. That is not pictured, but here I'm going to draw the CH3. So at carbon 2, highest priority is this carbon. Let's see. Why is that? The carbon here to the right-hand side, notice that the substituent of carbon 2 are this carboxylic acid, this chain, and then metal and hydrogen. So assigning priorities here, the lowest, and I'm going to do this in a circle. This is not the same as this number. This is for the chain. Lowest priority, I'm going to give it number 4. Second lowest priority is the metal. And then I am between carbon 1 and carbon 3. So if you check out what is attached to carbon 1, you count oxygen, oxygen, oxygen. So it's O, O, O. And when we do this carbon, it is attached to an oxygen, a carbon, and I have a hydrogen here. That is actually not pictured. I'm going to draw it. So I have, these are my substituents then to break the tie, because initially, yes, carbon, carbon, carbon. So to break the tie, I'm going to compare this. Oh, oxygen, oxygen, that's the same. So I go to the second. Oxygen has higher atomic number than the carbon, so that's my highest priority. Now, I'm going to do this in circles. This is different than that number 1. So doing the configuration of carbon 2, highest priority is this chain to the right-hand side. Second highest priority is this. Again, the numbers in circles is for the priorities. And so third is the metal, fourth is that. So next step is doing clockwise or counterclockwise. I see here that the hydrogen is pointing towards me. So to see the absolute configuration, we must see the molecule with the lowest priority group away from my view. This is not the case. Lowest priority is pointing towards me. So what I'm going to do is make a mental switch. So here, if you switch this to, now you will be, or we can do directly the configuration and make a switch. So let's do 1, 2, and 3. I have rotated counterclockwise. So if the hydrogen was in the back, then we'll be assigning S. But because it is in the front, I'm going to do a switch. So this center, carbon number 2, is R. So let's do the configuration. I need to erase some of those numbers because it's getting pretty crowded here. So let's erase this. Now I'm interested in the, how to erase it. I'm going to put the metal back. Okay, there we go. So now this is what we had. That is a metal. Now we're doing the configuration of carbon 3. And for carbon 3, priorities. Priorities go, Kang-Ingold-Prelog rule. Again, the highest priority, you need to see the atomic number of the atoms directly attached to the chiral center. So in here you can see, of course, this is the lowest. That's the lowest atomic number in the periodic table. And then you have carbon, carbon, and oxygen, so that's my highest priority. Again, the numbers encircled is for the priorities. Then I have carbon this one and this, which is carbon 2. So notice carbon number 4, this carbon is attached to hydrogen, 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 whereas carbon number 2 is attached to carbon number 1 and to this carbon into that. So actually carbon number 2 is attached to carbon, carbon, and the hydrogen that is here. So connectivity here, what is it connected to? Carbon, carbon, hydrogen. So comparing to break the tie, because in the first instance is carbon, carbon, but when I see this, carbon is higher atomic number than hydrogen, so this has higher priority. Now having the priority set, this is 1, this is priority 2, they change to the side, this is 3, this is 4, and what I need to do is follow those numbers. The lowest priority is in the back, so I'm going to be doing 1, 2, 3. So this center is R as well. So now we know this is following the rules for doing IUPAC. We did a few things to remember how to assign configuration. First thing is that's carboxylic acid. That's my main functional group. The parent chain must contain the functional group. In this example, this was easy. Acetic acid is a common name. Ethanoic acid is the systematic naming. It's saying how many carbons that we have. In the other molecule, we have 2 functional groups, so we need to assign priorities here. The carboxylic acid has higher priority in the naming than the alcohol. So that's why we said it's non-butanoic acid, and because of that, the hydroxy is now, the OH is now a substituent, so we call it hydroxy. The other substituent is a metal. When you have chiral centers, you must include the configuration in the naming.